All right, how's everybody doing today? I hope everybody's doing okay. Appreciate y'all coming to our Rio Data webinar on Postgres auto vacuuming tuning lessons from the field. Today, the presentation will be presented by Jessica Braxton, one of our senior cloud architects, and so I will turn this over to her. But I would ask if you guys have any questions. Please use the question and answer feature of the webinar, and we will monitor that and answer questions throughout the presentation as we can. At the end of the presentation, we will probably take a few minutes to answer to round out those questions and to make sure that we answer everything accordingly. So with that, I will turn it over to Jessica, and she will present today's presentation. Thank you.
Thanks, Bobby. All right. Nope. 1 second. Do this in the other order. All right, is my screen visible?
Yes, I can see it. So
Cool.
everybody else should be able to see it.
I seem to have turned on subtitles in PowerPoint. I don't know how to undo that, so I'm going to roll with it here. All right, so like Bobby said, I'm Jessica Braxton. This presentation is Postgres auto vacuum tuning, lessons I've learned from the field. If I would grab this contact information now, although you likely have it, but if we get to the end and there are still unanswered questions, reach out to us. Here's our contact info, and I can show that again at the end as well. If you're new to Postgres, some other places that kind of to flesh out your basic, your 101 questions, there is a Postgres community Slack and a Discord server. The Slack is an official, it's hosted by the Postgres group, the development group. A lot of the core development team hangs around there and answers questions. The Discord server is not official, but it's slightly larger and slightly more active. If you run into something and you still need more help and you ask your basic questions there or on the mailing lists, then you come back and talk to us. So how do you know if this presentation is for you? If you're a Postgres DBA, qualification number one probably there. If you're relatively new to Postgres or have been running with it for a while, but the auto vacuum is one of those things that it kind of works until it doesn't. And so you're still you feel like a new to Postgres person. Your first auto vacuum tuning exercise, this presentation is for you if you fit into that category. If your Postgres database has a lot of transactions and is large, this presentation is probably for you. If your queries are getting progressively slower and slower, you probably need to look at the auto vacuum. If you've got unexplainable wall buildup, which in turn can lead to replication slowdown, and you've pursued other avenues for troubleshooting and you can't figure it out, it might have something to do with the auto vacuum. So this is probably for you. This presentation is probably not for you if you're purely an application developer and the performance issue that you're having is going to need to be solved by code changes. I'm not addressing code changes at all in this presentation. Just be aware that is a lot of times the first line of defense, and then you get into auto vacuum tuning, but there have definitely been times where code changes are required for auto vacuum to keep up. If your database is older than 9.5, please upgrade. And this presentation also is probably not for you because several of the monitoring tools and other views and such that I mentioned are 9.6 and higher, which at 9.6 has been around for a while. So just keep that in mind. So what we need to understand before we start talking about AutoVacuum is Postgres, the concurrency control. Postgres uses a multi-version concurrency control model. It sounds a little scary at first. It's actually pretty cool. It provides transaction isolation, and we could get super into this. You could have probably whole half-day workshops on how multi-version concurrency control actually works under the hood. But for the sake of this presentation, we're just going to address that what it does in effect, if you're brand new to Postgres, it ensures that locks for reads don't block locks for writes, and locks for writes don't block locks for reads. Keep that in mind as we start talking about AutoVacuum, because there are some things to consider that will make sense with this in mind. So a question that I get a lot for teams that are new to, just migrated from Oracle to Postgres is, okay, so we've addressed the multi-version concurrency control. That's definitely a little bit different than other systems. And we start thinking, and okay, this means that Postgres is storing multiple versions of itself, right? It's in the name, multi-version concurrency control. So does that mean that Postgres is going to occupy a lot more disk space than Oracle or SQL Server or MySQL? The short answer is no. You're always going to have a high watermark, but as long as your vacuum and AutoVacuum are running, you're going to be able to reclaim some of that disk space. Now, it's never going to look like it's available from the OS level, but the blocks in your data files will be available for reuse. Common questions that kind of come on the tail end of that is, if there is heavy bloat, well, the database will occupy an increased disk space. And so bloat is when you go in and you have a change to a row. We will talk about that, but you're basically killing off old blocks, and they don't just go away until the database is vacuumed. And they still don't go away, but they're never going to be. They're just hanging out there, taking up empty space. That's called bloat. So you're going to have that watermark. If you're not vacuuming enough, this could lead to an absolute catastrophe. If you never ever, let's just say, because I do surprisingly get asked this a lot, somebody wants to turn off the auto vacuum and never manually vacuums, and the database is updated quite frequently, your database is at risk for going down. I have seen it happen. You have to have some form of vacuuming on. You just have to. You're also going to take some performance hits because less data is going to be found in cache. Okay, so what is the auto vacuum? I like to think of it as a kind of magic little thing that happens in the background usually. When it works, it's wonderful. It's absolutely wonderful. When it doesn't work, not so much. But I thought I would share this little comic strip because it cracks me up and always makes me think of Postgres AutoVacuum, because it's how my brain works. So in reality, this is more a more accurate representation of the AutoVacuum. What the AutoVacuum is doing is it's reclaiming storage occupied by those dead tuples, which is an updated row, a deleted row, something to that effect. It's that multi-version, so it's the older version of that data. in a normal Postgres operation, the tuples that are deleted or obsoleted by an update are not physically removed from the table. They remain present until vacuum or auto vacuum is done. This is why that's where that bloat comes from. That's what the word bloat is referring to. And this is also why it's necessary to do the vacuuming periodically, especially on frequently updated tables. Once you have a certain threshold of dead tuples, you're going to hit your transaction ID max, and that's when the databases go down. And you're going to have had a lot of other problems on the way, but that's the ultimate oh no, is when your database is down because you're out of vacuum. You have too many obsolete tuples and no more transaction IDs available to the database. So vacuum can be limited to a specific list of tables and material views. I don't necessarily recommend doing it that way because you're at risk for other tables getting neglected. It is important to note the difference between auto vacuum and vacuum. Auto vacuum runs on its own according to the parameters that you set. Those are the thresholds. That's when it'll kick off. There's no human intervention required other than the initial configuration and occasional tuning. You will see some, like with any maintenance operation, there will be some performance overhead with it. But if you can do the auto vacuum, if you can rely on auto vacuum rather than a manual vacuum, you really should. With the manual vacuum, if you do a vacuum full, which is the option that when you're reading through the documentation sounds the most appealing because this actually returns space back to the operating system. What it does is it rewrites the table, but you have to have a full table lock. And that may not sound so bad until you get into 7-8 terabyte databases. And I've seen this as low as, for tables as low as 500 gigabytes, I've seen the vacuum run into problems. But you're at risk for locking this table for anywhere from 3 to 7 or 8 hours, depending on the database, but keep it in mind. So this is when I'm talking about dead tuples, this is kind of an overview of files and blocks in Postgres. Pretty straightforward, nothing too crazy here. This will be important to understanding the transaction ID wraparound that I talked about. So you've got 8K blocks literally in the base directory. If you're new to Postgres, you probably don't know this, but in the base directory, if you navigate down, there's going to be a directory for each database in your Postgres cluster. And then inside of that, you're going to have these 1 gig files with 8K blocks. And then obviously you've got buffer cache, like with any database. These blocks are going to go back and forth between, you're going to put them in the buffer cache. Now, with the multi-version, yes, you're going to have a block. You could have a few blocks with the same, the same stuff in them. But for the header on each of these blocks, this is what the auto vacuum is looking at. There's a certain amount of information written there, and it puts almost like a version stamp on the block with the most current tuple. So it essentially creates a map. So you could have tuples in there that are in the blocks, in the files, that the user is never going to see, but it's still taking up space on your disk because it's an old, it's a dead tuple. That's bloat. What it does is, along with that, It'll freeze the old ones that are older than a certain amount, and you can change that amount. It's all on how you configure your database here. It will also assign each, in that same header, there's a transaction ID, and there's a finite number of transaction IDs that Postgres can have. So if you're not releasing those dead tuples, it can't assign a block for your new version of the data. It is a lot to get your head around. I highly recommend doing some extra research on it, but it is very easy to get lost in how multi-version concurrency control works. That's the high level of why it's important to, if you need to make an argument of why it's an important thing to keep the auto vacuum on, that should be enough. But it does lead the question, okay, so what do I watch in the database? I have not found the perfect answer to monitoring yet. You have your own choice of tools. There are a lot of different tools out there. I would recommend some sort of live monitoring, not, maybe set up a Grafana dashboard or something. I have a set of personal queries that I take around with me from from account to account. And a lot of times I'll plug those into a Grafana dashboard or something like that, so it's nice and visualized. Sometimes I can't do that, so sometimes I just get the output of the queries. But I would recommend having queries to spot check things, but I would also recommend having some sort of steady monitoring, so you have, you can do things like monitor the trends of the auto vacuum, do some analysis around there. You don't always, you want some data available, hindsight. The Postgres extension, the big one that you're going to utilize, you're going to use a lot, hopefully, but the big one for auto vacuum monitoring is the pgstat tuple view. So what you want to monitor, like what you absolutely want to monitor, in addition to a few other things, you want to know what your currently running auto vacuum processes are. This is extremely important if you have some sort of other maintenance going on, especially if it's planned. If you've got a big data import that is going to kick off at 1 a.m, you want to know that table, that auto vacuum isn't running on that table also at 1 a.m. You're going to create a lot of headaches for yourself. It's also good to just keep an eye on it. I like to log it. You can turn it on in the Postgres logs. It'll log when the auto vacuum ran, if you have things set appropriately. And you can make sure that it's not running on the same table night after night after night after night for 6 and 7 hours, because if it is, if you see that trend, you've got a little bit of work to do. The other thing that you also want to watch out for is you want to know how many auto vacuum threads are in use at any given time. The default is 8. Usually not all of them are running at the same time. But if you do have all 8 threads running, you want to know. Max auto vacuums, like I said, the default there is 8. Most people leave it at 8. It's usually sufficient. If you do set it to higher than 8, you really want to be aware of that, or somebody on the team sets it. You want to be aware, because you could run into work mem issues, and like I said, like auto vacuum does require there is some performance overhead and some resource overhead. You want to be aware of your disk writes and the efficiency, to avoid performance problems. You also want to be generally aware of when the last auto vacuum time per table was. You don't have to be super perfect about keeping track of that, but if you've got some problematic tables, you do want to keep track of that and do some analysis. You want to definitely, for sure, 100% be aware of all of the auto vacuum related parameter values in your PostgreSQL conf. You also do want to keep an eye on disk IO and CPU usage. In general, maybe yes, but I'm specifically referring to peak AutoVacuum hours. Historical information is important to track. If you find yourself having to tune the AutoVacuum and you don't have any historical monitoring data, good luck. Get some historical data. You're going to have to create some. You're going to have to do some benchmarking as well. You want to know how long the AutoVacuum ran, how many times it ran on a table. You want to know the frozen tuple age. And when I say frozen tuples, I'm referring to the tuples that have been flagged as never, ever, ever going to be seen by the user. It's an outdated version and it's older than, whatever it is that you've got the threshold set to. You also want to be aware of XID stands for transaction ID consumption. So if you're burning through transaction IDs, you're going to want to know that so that you can look at more aggressively setting the AutoVacuum. You also want to be aware of long-running transactions. In general, that's good practices to know, right? Usually. But if you want to correlate this with the AutoVacuum, because if you're not aware of these long-running transactions and you've got AutoVacuum running and there's a transaction waiting behind it, AutoVacuum doesn't do a full lock on the table, but it does do a full write, tuple by tuple. So there is going to be some locking happening. And if you've got a user trying to update something that AutoVacuum, like an exact row that AutoVacuum is working on, you're going to get a phone call. So it's nice to be ahead of that. And it's nice to know the historical long-running transactions in correlation to when the AutoVacuum was running, because you can do some predictive analysis. And if somebody keeps trying to run the same query or it's scheduled at the same time and the AutoVacuum kicks off at the same time every single night, you can get ahead of it a little bit and say, hey, let's schedule this query to run at a different time. Let's make sure the AutoVacuum is not running. So how does the AutoVacuum, how do we even look at those parameters? These are all going to be in the PostgreSQL conf. The AutoVacuum, one big thing that it uses as a threshold to, as for when to engage is it goes by IO points. Well, what is an IO point? These are the big three: vacuum, and these are all in here as vacuum, but for every vacuum parameter, for almost every vacuum parameter, there is a duplicate and it says AutoVacuum. So I left them in here as vacuum, but just assume that, auto is also in front of this. So you've got your vacuum cost page hit. That's the cost of vacuuming a buffer that was in the buffer cache. Pretty low. It's only, 1 point usually. The vacuum cost page miss. And I wrote this backwards on this slide. This is the cost of vacuuming a buffer. This is when you miss the buffer cache. Page miss. So excuse my mistaken copy and paste here, and I did that on all three. That's embarrassing. What happened when I was editing this? Okay, well, vacuum cost page dirty is the big one. When you have a lot of dirty pages, AutoVacuum is going to be a little more excited to turn on. Okay, so how do we control the IO impact? We set the AutoVacuum cost limit. So this is a global setting across all the vacuum processes. You can't set this like individually. Like if you have one database that you want, a lot more is going on in that database in the same cluster than the other one, too bad. The threshold for AutoVacuum is the same. So the cost limit is the total points of those IO points added up. That's all you're allowed to do before the auto vacuum delay period, which is how long, that's the threshold to say how long, at what point do I've written it here as before the auto vacuum will strike again. Humorously, because we want it to run, right? But sometimes it's a pain in the neck. Okay, so other relevant things, you want to know what your maintenance work mem value is. This is inclusive of all of your maintenance related backend processes, but it is inclusive of things beyond auto vacuum. So it's not, in other words, it's not dedicated to auto vacuum, but you do need to be aware, like I don't think you can, well, I don't want to say I don't think you can set it to be to the auto vacuum have more than the maintenance work mem, but it's definitely possible. But you don't want to look at that and think, oh, great, that's how much auto vacuum has to use. You want that always to be higher than what you expect the auto vacuum to use. Otherwise, things like your backups and such are going to crap out and not have enough memory. You just don't want that competition there. The other one is the auto vacuum work mem. By default, that's the same. That's the max, the high level of the maintenance work mem. But this is specific to, this is auto vacuum's work mem allowance. I recommend setting that to a little bit below the maintenance work mem, but make sure you document that change very well. Because otherwise you may assume that you've got the full maintenance work mem available and wondering why auto vacuum is only using so much. And yep, it's because of that. So make sure you know what those parameters are. So the auto vacuum, with the row freezing, there are some things to consider, some trade-offs here. The vacuum and auto vacuum freeze min age by default is 2 million. The highest you can set this to is 1 billion. And all this is this says how old does a transaction ID have to be before we freeze it. And my grammar here is a little bit off. What this really means is, what is the oldest, per table, what's the oldest before we start freezing transaction IDs? To set this at the table level, we've got the auto vacuum freeze table age. The default here is 150 million, a little bit more aggressive than the other one. This is usually, so it's 80 to 90% of the auto vacuum max freeze age. Watch out for this. It sounds more aggressive because it is. What this is how old can a table's oldest transaction ID be before we trigger an aggressive vacuum. I've seen this bite a lot of people. It's because it's by default set more aggressively. You definitely want to watch out. When it reads every single block, the auto vacuum takes longer. You've got more write ahead log file generation. So if you've got other, let's say you've got a separate issue and your replication is struggling and you have this aggressive auto vacuum kick in that's reading every block, it's not going to help your replication situation. Hang on. All right, duplicate slide, sorry. Okay. So the auto vacuum freeze max age. And I'll be honest, the parameter names, keep a spreadsheet or something somewhere with the short and sweet. Create a cheat sheet for yourself. Don't try and memorize these. I get the words backwards on them all the time. It's easy to do. And on some of them, it really matters because on some of them, the wording is very, very, very similar, but the function is very different. So with that being said, side tangent there. The freeze max age is 1 billion or higher by default. And this is the opposite end of the freeze min age. So silently, these settings are, I suggest playing with them a little bit and running something like pgbench to generate workloads against a sandbox database, maybe, to really kind of test these. You could look at the core code, I suppose, but I'm not strong in C++, so, or C++. This is going to limit the freeze min age to half of this max age, and that's going to override it. So just make sure that you're looking at those two in relationship to each other, because even if one is set, if the freeze min age is set lower than half of this, one of these is going to win out. So to bring it all back together, a table needs to be vacuumed if the number of the dead tuples exceeds a threshold, or one of those other things that we've talked about kicks in. But the bottom line threshold here they come down to these two factors, the analyze threshold and the scale factor. So the scale factor is your, see, this is why I recommend having a cheat sheet. Brain farting on this. Go look this up. I may be wrong about this, but I believe it's the dead tuples, the percentage of dead tuples, plus your minimum size of the table. So if I've the analyze threshold, if I've only got 2 rows in a table and I make a bajillion changes to those 2 rows, and my analyze threshold here is set to 5, that's my minimum required, 5 plus the 0.2% of dead, yeah, I'm probably never going to hit an auto vacuum, which is a problem because you hit that on, it only takes 1 table to hit your max transaction IDs and kill your database. So this isn't the only trigger for the auto vacuum, but this is the big one, and I do recommend double checking on these, looking up the definition for yourself and doing the math as well, but this is the general formula. All right, so practical application. A lot of times auto vacuum issues can be fixed by a code rewrite or a rethink on the code design. I've seen quite a few databases where the application intentionally rewrites or re-updates the row almost nonstop over and over and over again for 12 hours. That's just really, 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 really ridiculous for a lot of reasons. One really large reason that particular example is bad is because, keep in mind, we haven't talked about indexes, But if you have to update your indexes are going to have dead tuples as well, and your indexes are going to need to be either vacuumed or auto vacuumed in addition to your regular tables. So yeah, just one example of many ways that bad code can affect, cause a lot of auto vacuum activity unnecessarily. You want to take a realistic approach and a reasonable approach to how much bloat you can tolerate. You are never, ever, ever, ever going to see a database that never has any bloat, unless it's the database on your laptop that's for you to play with. Then maybe fine, you might see minimal amounts of bloat. So you want to kind of baseline your performance, and there is a line, and you do need to do a little bit of work to find it, but there's a line where this amount of bloat is kind of okay, but once you get above a certain line, a certain amount of bloat, auto vacuum starts having to work harder. Queries start slowing down because it's having to scan a greater distance to find, depending on how you're actually writing your queries, but it can cause your code to slow down. This is an area where I do recommend to be more aggressive when you can, because a lot of times code changes are somehow code changes can seem like a bigger deal to the business than changing a few database parameters, which I feel like is backwards, but I'm a DBA, so hey, my bias there. If you want to be more aggressive with the auto vacuum, raise the, in addition to looking at the threshold, you could lower that threshold, use that formula to set those parameters to have a lower threshold. But other things that I would do first before looking at that is to raise your auto vacuum cost limit, lower the auto vacuum cost delay, which is that wait period. Auto vacuum is going to wait. It's not going to run and then immediately run again on the same table. There is a delay, and that's how you would set it. You can increase or lower it, but lower it to make it more aggressive, and then also lower the auto vacuum scale factor, which is part of that threshold formula that we talked about earlier. So, losing my voice. Other things to kind of watch out for, excuse me. Be cautious when you're adding new indexes. I'm absolutely not saying never add an index, but be careful because it does add to your auto vacuum overhead. Definitely take advantage of maintenance windows. Like I have a few databases, or I've had a few databases over the years, I should say, that auto vacuum, things had just gotten so bad that auto vacuum really couldn't keep up. We really needed to, excuse me, to manually vacuum. So we took advantage of some maintenance windows, because if you remember, like I said earlier, there are different options for vacuum. You can do vacuum analyze, vacuum full. I would definitely look at those before you run vacuum manually, but for the full, which is what we usually end up doing, it does require that full table lock. So you do not want to run that in the middle of the day. You don't necessarily want auto vacuum running in the middle of the day either, or in your business, high business activity hours. It's ideal if auto vacuum is running after hours, but with auto vacuum, you can't necessarily control that. You can only influence it. With vacuum, you can directly control it. It's up to you when you run vacuum. I just, make sure you have a maintenance window for it. Table partitioning can sometimes help with auto vacuum, help take the load off of it a little bit. But it's easy to mess a lot of things up. Be careful, plan thoroughly before you do that. Ideally, you want to look at the code and see what you can change in the code. Now, if you're in the line of fire and your bloat is about to take your database down, don't waste your time looking at the code. You need to solve the problem now, but bookmark it. And, when you're doing your post analysis, see if you can look at the code and see if any of the code can be running more efficiently. So I have this on a whole slide all by itself because excessive wall generation. Okay, you can generate more walls than you expect for a number of reasons. My favorite one is when the AutoVacuum is struggling, and as a byproduct, you have significantly higher wall generation than you normally do. Now, in an environment where both of these are going on, and I think I kind of touched on this earlier, but it's because it keeps coming up and it's always a very sensitive thing for clients. They'll have one team over here because queries are slow. They're blocked queries because AutoVacuum is running, and a user is trying to query that exact set of rows that AutoVacuum is working on. So the query just hangs forever and ever and ever. And usually it's like 2 or 3 minutes, but they're used to seeing it back instantly. So they get phone calls, or we get phone calls. So you've got the attention on that, and somebody will happen to notice that, oh, AutoVacuum has been running on this table for 6 hours. Oh, hey, that's the same one that ran last night and the night before, and so this attention gets turned onto the AutoVacuum. Meanwhile, you've got other users, a lot of times monitoring teams or system administrators, and depending on your environment, they're watching the standby database, preparing, depending on the SLAs and the recovery requirements. In a lot of the ones where it's zero downtime, full recovery absolutely required, we'll have another team over there going, hey, replication is slowing down. So then you start splitting into 2 different directions of troubleshooting, and you get into the replication stuff, and you see that replication is slowing down because it can't keep up with the wall generation. Well, hello, because AutoVacuum is struggling. So it's sometimes hard to plug in all of those pieces back together. But if you do have excessive wall generation, make sure, just process of elimination. AutoVacuum is not the only thing that can cause that, but it can definitely be an unexpected side note. If you've got a team that's used to being very compartmentalized and doesn't necessarily look at all the holistic picture, pieces of the picture altogether. And this is also a problem. You do want, if you have, in the other direction of this, if you have an AutoVacuum, I don't want to call it an issue, but if you know that you require some tuning to keep the database going, keep an eye on that wall generation, because you could run into a lot of problems if you start to exceed, maybe archiving isn't working or something, so you're not getting that turnover and you grow beyond the disk space. Hopefully that doesn't happen, but you don't want it to. If you can avoid a problem, why not? So that is something that I probably should add to the monitoring section of this. There are a few different ways you can check. What I like to do is I like to monitor wall generation over like an hour period. I will literally just check the disk space, set up a script to do it for me, and watch the trends over, either when I know the AutoVacuum is running or just in general, every now and then I'll go spot check some databases during what I know as their peak hours. And I'll just tuck that information away for later and keep it as a baseline. And when things start going above that, I know I'm going to have a problem. But I mean, also, if it's getting close to the limit on my wall directory, that's also a problem as well, obviously. But anyway, so that is a high level on AutoVacuum. You can make it a lot more complicated. You don't have to. That's your starting point for tuning. With that being said, I know that was a lot to take in. Do we have any questions?
We had 3 questions come in, but I pretty much answered them
Cool.
throughout the presentation, Jessica. So I think we're good there. Unless anybody else has got any additional questions, please use the question and answer options of the webinar, and we will get those answered immediately, live on the air while Jessica's available.
Yep.
All right. I guess nobody's really got any more questions, so we've answered all the questions. So I think that's pretty much it, Jessica.
Cool. I will stop sharing. Oh, I lost my mouse.
Oh.
There we go.
All right. Well, thank you everybody for attending today's webinar. We appreciate it. If you have any additional questions or want to know more about Rio Data and how we can help you in your environments with either Postgres or Oracle or cloud in general, please feel free to reach out to us and let us know. Thank you for your time.
Yep. Thanks everyone. Oh, the undo question.
Well,
it's so disappointing. I mean,
the
truth is disappointing.
Why can't I stop recording?
Oh, I think I have to.
Oh yeah, you're a host. That's why.
Well, can I give that back to you? I
got it.
Okay.